Hi, in this video we'll be looking into another subtopic under real numbers for ZIMSEC O Level Maths, and that's going to be covering approximations and estimations. And for this, we'll mostly look at rounding off numbers, decimal places, and significant figures, and also limits of accuracy. And then we'll look at estimations in the next video. So for approximations and estimations, the first part, which deals with significant figures, there are certain rules that help to guideline whether a number is whether you can round up or round down when you are asked to put a certain number to a specific significant figures. So any digit that is not 0 is significant. For example, here we have 1.234. That has 4 significant figures because we don't have a 0. And then the next rule is that zeros between non-zero digits are significant. For example, we have 606. So in 606, this 0 is between two non-zero digits, which is the two sixes. So it has 3 significant figures. But if we had 660, for example, that would be 2 significant figures. Because now, when you look at it, the 0 is not between any non-zero digits. It's after the 2 non-zero digits. So that's why we have 2 significant figures. And then the next rule says, zeros to the left of the first non-zero digit are not significant. For example, 0.08 has 1 significant figure. So when we look at it, we have the first non-zero digit is 8. And then zeros that are to the left. So 0.0, those are non-significant. So we have only 1 significant figure. And then the next rule says, for decimals less than 1, only the zeros at the end and in the middle of the number are significant. So again, when we look at it, we have 0.00420. So these 3 zeros are non-significant because they are on the left of the first non-zero digit, which is 4. And then we have 420. But because this 0 has been added after, at the end of the significant figure, which is the 2, it is also significant because it was added intentionally instead of if it had just been 0.0042, right? That's the same value, but this one is 2 significant figures, while the one that we have up there is got 3 significant figures, right? And for the zeros in the middle, so again, looking at the same of this number, 0.00, those are non-significant. Then the 402, that is significant. So 3 significant figures as well. And then for a number greater than 1, zeros to the right of the decimal places are significant, right? So intentionally adding a decimal place or numbers after the comma, which are zeros, those are significant. For example, 2.0, that means both 2 and the 0 are significant. So 2 significant figures. So now looking at rounding numbers to a given place value, right? So let's say you are asked to round a certain number to a given number of decimal places or significant figures, right? First, identify the digit in the required place value and circle the number to the right, right? This will determine whether to round off or round up. So, for example, if we have, let me say, 4.397, and then they say, put this to 2 significant figures. So the first thing is they identify the digit in the required place value. So we want 2 significant figures. So we have 1 and 2. So circle the number to the right. Now circle 9 because we already know that 4 and 3 are going to remain. So circle the number to the right, which is 9. That's the first number. So if the second number is 5 or more, then you round to the bigger number. So we round up, right? So just 2 significant figures. These will be 4 point. So because 9 is greater than 5, we then add 1 to 3, then it becomes 4.4. So that then becomes 4.4 is 4.394 to two significant figures. But if the second number is less than 5, then you round to the smaller number, so you round down. So let me say an example where we had, if we were given a number like 5.9231 and asked to three significant figures. Again, we look at what we are given, and that's 1, 2, and 3. Those are the three significant figures that we're looking at. And then the number to the right of that is going to be 3. That's the digit to the right. And now we have to look at, is 3 greater than or less than 5? It is less than 5, so we round down. So 5.9231 to three significant figures will then equate to 5.92. Is the answer. So that's how you go about it. So then it says, if you then put a 0 in any following place values before the decimal. If you're rounding to the nearest decimal, then make sure you leave your answer to the required amount of decimal places. So that part is important. Do not put unnecessary zeros, because that can change the number of significant figures or decimal places once you add unnecessary zeros. So for example, we have 1297 as to put it to two significant figures. Again, we mark which ones are the first two significant figures. So 1, 2. Then the third place is with a 9, which is greater than 5. So we round up. Then that means plus 1 to 2. And then that translates to 1300. Okay. And for the next example, we have 3.497 to two decimal places. So this is decimal places. Again, we have to check, this is the first decimal place, this is the second decimal place. So you have to understand whether it asks for significant figures or decimal places. So the number to the right of that, that's going to be 7. So 7 is greater than 5, so we round up. So our answer is going to be 3.50. Since 9 plus 1, that's 10, and then it is up to 3.50. That's two decimal places. So yeah, then just an additional number of rules. Rounding to significant figures is the same as rounding to place value. You just need to identify the place value. So that's the whole point of identifying which number has the significant figure that you want and what number is the digit to the right of that. So find the biggest place value that has non-zero digit. So the first significant figure for 3097 is 3. First significant figure of 0.006207 is 6. So know which one is the first significant figure, which one is the first decimal place. So in this case, 6 is the first significant figure, but 0 is the first decimal place. So just watch out for that. So start with this number and count from the left to the right. That's what we're doing for the examples that we did. So in this exercise, you're asked to identify how many significant figures are in the following. So you can do A to E. I can do B for example, where we have 0.002110. They say how many significant figures are in the following. Again, going back to the rules that we did, the zeros for numbers less than 1, the zeros just after the comma, before, and non-zero digit are insignificant. So these ones are non-significant. So the first significant number is 2, and this 0 is also significant since it was intentionally placed after a non-zero digit. So that gives 1, 2, 3, 4. So that has 4 significant figures. So you can try the rest of the exercise from A to E. And for exercise 2, it asks you to express a certain number of questions to different significant figures. For number 1, 3 significant figures. For number 2, to 2 significant figures. For number 3, to 1 significant figure. And then number 4, to certain number of decimal places. Number 5, to significant figures in decimal places. And number 6 as well, determining the significant figures. So you can give these a try. I can show you, for example, let's try question number 4, where we look at 4C, right? We say 0.0486 to 3 decimal places. So these are decimal places. So again, we'll mark where our decimal places are. So it's going to be 1, 2, 3. And then we have to look at the number on the right, which is 6. So 6 is greater than 5, so we round up. So then our answer becomes 0.049. Right. So that's 3 decimal places. So you can give the rest of the questions a try. And if you have any questions, do feel free to attach them in the comments. And then exercise 3 is just additional practice questions, but under the same basis of rounding numbers to 1 significant figure, rounding numbers to 3 significant figures, and rounding numbers to 1 decimal place. So I can give a try to, let's say, number 1B, which says round each of the following to 1 significant figure. So we have 22. So 22 to 1 significant figure. That's going to be 20 because 2 is less than 5. Or I can also try number 1, let's say S, 6,349 to 1 significant figure. Again, my first significant figure is 6, so I look at 3. That means we have to round down because it's less than 5. So that means 6,000, and the rest becomes zeros. Okay, and then for number 6, round each of the following questions to 3 significant figures. I can try number 6B likewise. So we have 1,891 to 3 significant figures. Again, 1, 2, 3, and then the number to the right, that's 1, which is less than 5. So that becomes 1,890. And then next question, I can try L. Okay, L is part of that. I can try K. So K is 0.08906. Again, to 3 significant figures. So the significant figures start from the first non-zero digit after the comma. So 1, 2, 3, and 6 is greater than 5, so we round up, and then we end up with 0.0891. That's 3 significant figures. And then for number 2, round each of the following numbers to 1 decimal place. So I can try L, which says 637.51 to 1 decimal place. Again, I look at where the first decimal place is 5, and then the number to the right is 1. So rounding that down, since it's less than 5, I get 637.5. And then I can also try H, 29.26 to 1 decimal place. Again, the decimal place marker, the first decimal place is 2, so the number to the right is 6, which is greater than 5, so we round up and the answer becomes 29.3. And let me try L as well, because I think that's a unique example. 9.99, and we've been asked to 1 decimal place. The first decimal place is 9, the number to the right, that's 9, so we round up since it's greater than 5, so it becomes 9 plus 1, that's going to be 10, again carries on plus 1, that's going to be 10, so that's going to be 10.0. And that's important because they are specifically for 1 decimal place, so these would not be equal to just saying 10. You have to actually put the decimal place, which is going to be 10.0. And then for number 7, you can give them a try because it is the same set of rules and format as before. And now when we look at limits of accuracy, right, when you look at, let's say, a ruler, on a ruler you have the graduations, right? Let's say you have a ruler, and on the ruler you have certain markers, and on those markers you would have, let's say, 1 centimeter, 2, 3, 4, 5, 6, right? And a ruler is therefore accurate within those markers depending on how fine the calibration is or the precision is for that particular ruler. And sometimes then there is a limit to accuracy in that it could be maybe a close something close to 1 or something close to 2 or something close to 5, but at the same time usually you round up or down within a certain range of accuracy, right? Because you're not so sure that it's going to be, let's say, 1,001 centimeters. You're only sure within the accuracy of what the ruler is graduated to. So in this case, you're more likely safe within 1 centimeter than to be sure that there is actually 0,001 more, since the ruler doesn't show that. So limits of accuracy, so it gives a range which a number might fall to a certain degree of accuracy. To say sometimes there exists an upper bound and the lower bound, to say if you round this up or down, you end up within this range. So the range within which if one rounds off a number, it would go initially given the level of accuracy. So if you have 0.06, 0.06 is x if measured to 1 decimal place. What are the limits? So it's asking which 2 boundaries can we get such that if we round them to 1 decimal place, we would still get 0.06. So that means you need an upper bound and a lower bound. So when we look at it, 0.6 has 1 decimal place. That means we would have rounded off 2 decimal places. So things within 2 decimal places would be rounded off to give us 1 decimal place, which is 0.6, right? So in this case, if we subtract if we add 0.05, we get 0.65, and we subtract 0.05 because remember 5, if we had 0.65, 5 is the marker which makes us determine whether we round up or down. So anything above 5, we round up, so then it stops being 6. Anything below 5, we round down. That means it still remains 0.6. So it means that we have a second decimal place that we can round up or down to 1 decimal place to get 0.6. So in this case, that's why we add and subtract 0.05. So the upper bound will be if we add 0.05, we get 0.65. The lower bound is if we subtract 0.05, which is going to be 0.55. So now when you look at it, so it also requires that you know inequalities. So in this case, any value between 0.55 and 0.65, if it's rounded to one decimal place, we will get 0.6. So for example, if I take 0.56 to one decimal place, again, one decimal place is 5, and then 6 is above 5, so then that becomes 0.6. If I take 0.63, right, because that's also between 0.55 and 0.65. Again, 6 is the first decimal place, 3 is less than 5, so again, that's going to be 0.6. So when you look at it, you're trying to find what numbers give you the range at which anything between those two can be rounded to give you 0.6 to one decimal place. So looking at this, anything greater than or equal to 0.55. So this equal to is important because even at 0.55, rounding it to one decimal place, you get 0.6. But anything less than, not equal to, because once it's equal to, it becomes 0.7 when it's rounded up. So anything less than 0.65, right, becomes 0.6 when rounded up. So you just have to know about where the current decimal places are and where the limits of the upper bound is or lower bound. So when we do the next example, we have 0.67. And we're trying to find what range of numbers. If we round it to two decimal places, we will always get 0.67. So when we look at it, we have the number of decimal places. We have 1 and 2, right? That's the two decimal places. That means that we have to add a third decimal place, which is a range at which we'll be rounding now up or down to get two significant figures, right? Two decimal places. So in this case, it's going to be 0.67 plus or minus 0.00 because we have these two, 1, 2. So we also put 1, 2 decimal places and then 5 because that is the third decimal place that we have to round up or down to get the upper bound and the lower bound. So again, we add that to 0.67, we get 0.675. We subtract that from 0.67, we get 0.665. So now that means that our range or limits are 0.665 less than or equal to x less than or equal to 0.675. So any number between these, when rounded up or down to two decimal places, will give a 0.67. And you can try any number between that range. So an example then would be what's captured in the ZIMSEC past exam for June 2012, part 1, where they say a rectangle is 9.1 centimeters long and 5.7 centimeters wide, correct to one decimal place. State the least possible width. Excuse me. When you look at the width, it's 5.7 centimeters, right? But this is to one decimal place. So again, you have to find the limits by adding a second decimal place to say what's the range of the width. And then find the limits within which the perimeter of the rectangle lies. So you have to know the formula for the equation of a rectangle, the formula for finding perimeter of a rectangle, and also knowing that the length and the width will both be within certain limits. And likewise for June 2016, part 1, paper 1, there's this question on part 3b. A length h is measured to one decimal place. A length h measured to one decimal place is given as 9.5. So again, look at what the measurement is within the accuracy and what the number has been reduced to. In this case, one decimal place. And they ask you to state the limits. So you can give that a try as well. There will be a video to explain or give more details about the past exam papers per topic. And yeah.